Hey everyone, look at this. What we have here today is a double button carbon microphone. This is a replica of a microphone from the 1930s, and what this is going to allow you to do is 3D print your own. Now let me explain what we're looking at here real quick. This is the body of the microphone, and this is the faceplate. And in each one we have a chamber that holds carbon granules. And of course we have the terminal screws here. We're going to put an actual threaded screw through these, but these are where the electrical terminals go. You screw it in here and you can adjust the pressure on the carbon. More on that in a minute. But these get filled up with carbon, and then there is a diaphragm stretched across the entirety of it. We use this ring to stretch the diaphragm on this model, and once the diaphragm is stretched across that, when you talk, the diaphragm vibrates, and it vibrates the button that touches the carbon, and that changes the resistance in the carbon. So the carbon becomes a variable resistor, and that's how we generate our sound signal. So how it works is the terminal screws get put into place, and that'll hold the carbon, and it will hold the actual terminal metal screw. The buttons are kind of interesting. We have these that have a little hole in the side, and what we do with those is we run a wire in there through the side and down to the bottom. And then we take another one and we stack it on top to make a nice little sandwich with the wire coming out the center. The bottom of this one is placed into the carbon chamber, so it makes contact with the carbon. I've also been soldering a little metal washer to the wire through there for better and greater contact. But the bottom of this comes in contact with the carbon. The top of it provides a nice even surface for the diaphragm to rest upon and vibrate. And what happens is then we connect the wire off of the button through this hole right here, to the back of the terminal. So the completed circuit will come in through the terminal into the carbon chamber, go through the carbon, up to the top, it will connect with the button, and then it will go back out again through the buttons wire. And it will do that for both sides of the circuit. The double button carbon microphone. You can build it as a single button microphone and leave this off, but it requires a slightly different circuit. And this is a double. It has greater sound detail, which is pretty cool. So what we're going to do is we are going to 3D print and assemble this thing now. Alright, ladies and gentlemen, now what we're looking at, besides the world's jankiest soldering iron heating up, is actually the 3D printed parts of the microphone. And what I have here is the body of the microphone with the carbon chamber, the tension ring, and the buttons. Now, for the button plastic, they have a little hole in the side, and we've run a wire through that already to the bottom where it will contact the carbon. But since we want more solid contact, what I've got here is a brass washer that I've already got a little glob of solder on, and I'm going to try to get that to adhere to the wire that I've got going through this button. Oop. And if I can do that without completely melting it, we're gonna have a good time. Or dropping it. Dropping it is not good. There we go. Which is why I pre-applied this, so that I can kind of brace it on our thing here. Uh-oh. There we go. I did mention that this is the world's jankiest soldering iron. But yeah, no, I need to get that a little lower profile here. There we go. That should do it. Uh-oh. We'll wait for that to cool down so I don't stretch it as I pull it. It is made of plastic after all. While I wait, we're going to apply solder to this one as well. which is a lot of fun. Trying to apply a solder glob to a piece of brass. This soldering iron really is terrible. Alright. Let me get a knife here. There we go. Nice. Okay. So again, we will take this brass washer and get it soldered to the wire coming from the button. Melt, would you? There we go. Okay, let's check that connection. Yay, okay. Uh-oh. That's still a little warm. We might have our button deforming, so let's just kind of nudge it back in place before it cools. That's one of the dangers with really thin plastic like that, but I think we ought to be okay. Oh, why does it stay so hot? Cool down already. You know what? Run it under a little cold water. There you go, you little monster. There we go. Now we have a little ridge on that. Luckily I have some shears, and we're going to clip that off. Yay. Okay. Now we have got two buttons with brass washers. And that means we can continue to put this together. So let's unplug the soldering iron so that we don't burn the house down, and set it aside. Okay, good news. We have replaced the world's jankiest soldering iron with a hot glue gun. Now, why do we have a hot glue gun? Because these are the bottom halves of the buttons. They face into the carbon chamber. We need the top half of the button that faces the diaphragm and provides a smooth surface for it to contact with and push on. And it makes a little sandwich so that if you wanted to put like a felt washer in there or something to keep the carbon from coming out, you could. But what we're going to do now is to check on those and make sure that they are reasonably smooth and flush, and they're about as much so as we're going to get it for this particular video. So you'll notice there's a little pip on the side of this. It should fit into the little hole on this, more or less, and so that's how we are going to assemble it. We are going to put a little teeny drop of hot glue. We are going to put a little teeny drop of hot glue right there, and we are going to quickly insert that little pip into the hole in the middle. And try to smoosh it around and get it as even as you possibly can and centered as you possibly can before the glue sets up. And so now, yeah, we have a couple of little buttons that are going to go into the mic. The one for the base is actually a little bigger than the one for the faceplate on this design, and I see I might have got that a little offset. I might have to redo that, but I think it'll be fine. As a matter of fact, yeah, I think it'll be okay. We'll find out. Alright, so, next step. As I said, you can use felt, but I have cut a little paper washer to go around each of these, and we're going to put like a little dot of glue on the inside of the cup to keep them in place. Now, it might be hard to see on this print, but there's a little notch here next to this hole for the screw, and that little notch is where your wire is going to rest, and we're going to route it around the outside. But first, let's get this little washer attached. So, making sure that it's even in the center and setting it aside a second, we're going to carefully add a little ring of hot glue, and then equally carefully line this up. There we go. Boop. Well, I say that, but then I proceed to screw it up, which is okay. But I'm going to have to keep my thumb on it for half a second until it dries. There we go. Yeah, see, there's still play, but the washer should keep everything in place. There's a little gap right there where I didn't get the washer quite right, so what we're going to do is just kind of glom that a little bit with the hot glue and see if we can't make up for it. Okay, there you have it. Now, make sure that's smooth and doesn't come up above the level of the button. We also notice that the button does move and spin freely, despite the fact that it is inside a little paper washer. We're also going to press this wire down into that divot so that it doesn't interfere with the diaphragm. And there we go. See? That should move freely. There it is on the other side, but it should keep the carbon from escaping pretty well. Not going to guarantee that it's not going to escape at all, but and then the next step is going to be to route this wire around and then put the screw through, but we've got to do it on the other side as well. So let's see how much of this wire we are actually going to need while we're at it. We're going to put it in the wire channel. Yeah, so I can strip it probably at about here. So I need to cut a little bit of that off. So I'll be right back. Here's the one for the front, and we're going to go ahead and put that one on too while we're at it. And this one is going to pretty much just be a thing by itself. So yeah, be sure we've got that centered. Make sure that it's happy. And get us a little bit of hot glue. Yes, I know you're not supposed to put hot glue guns on their sides. We'll deal with that in a minute. There we are. So that should hopefully keep the carbon from leaking a little bit. So now that we've got the buttons in place, and you want to make sure that they can kind of move freely, because when they touch the diaphragm, they are going to need to move freely. You also kind of want to get a look at the profile and make sure that they peak up above the edge of the little rim here, because once the thing is on, like, you want to be sure that they're going to come up above that. And so if they do, you are in business. And I have like a larger ring here so that I can pull it back off. But yeah. And if it's not high enough, you can add a little extender button, which is always fun. So like, you can take this and you can glue it on top of that. And that's what we're probably going to want to do with this one, because that one is a little short. And so, let's take a little dot of glue and make sure we are actually rolling so that I don't not record this. There we go. Not glomming hot glue all over everything is the most challenging part of this project. And before it dries, be sure it is flush with whatever you want it flush with. There we go. Now, as you can see, I've routed the wire out the front of this thing. Currently, I have no better way of doing it, so that's how it's going to be. And since we've got our buttons in place, and we can actually put another one on here, I think. Yeah. I'm trying not to get too much nor too little. And, oh shoot. There we go. Now, we've got our carbon buttons in place, which is great. Also, again, we have a little gap on this side, so let's just fill that in and clean it off. There we go. We can use our little nips to grab parts that are not flush or clean or raggedy and get that going. Okay, so we've got our buttons installed. Now let's have a word about the diaphragm material. A lot of times I've been using aluminum foil as an experiment, or I've been using like this Mylar stuff that comes with hard drives, because it does not stretch and it's very resonant and it's stiff, and you can pull it taut and it won't deform and it won't like and it won't stretch, or it won't plasticize. So we need something stiff and reasonably resonant. And for this particular build, I have decided that I'm going to try the cellophane off of a CD cover, because it's very thin, and I'm hoping we're going to get a decent sound quality out of it, as far as sound quality is going to go on this thing. And so we're going to go ahead and cut this out. I'm going to try to be greedy and get 2 out of this. Let's just hope it doesn't backfire. Yeah, alright. I think we might be able to. I'm going to leave it like that so I have a convenient handle, I think. We're going to cut off the corners and round them off, just so it fits inside our mic body a little nicer. Try not to touch the part that's actually going to resonate and get fingerprints and things like that on it. Yeah, it'll go that way, so let's route our wire first. So our wire's going to go down in this channel. Actually, why don't we stick it out the bottom first? And get it in our channel. That'll get this out of the way while we yeah. Just a little dot there to kind of keep it from running off on me. And we'll push it down in there so it's out of the way. All right. If we twist the wire together, we don't have a million little strands that are fighting me. We just have one that has escaped that it is fighting me. Alright, okay. So now let's take this screw that's a little too big for our purposes, but oh well. And we're going to drive it on through here, because that is going to be our ground terminal on the back of this thing. And I am going to have to drive it a little further through there. There we go. Okay, ground terminal, and we've got our wire here. We will connect it properly later when we get the other one on the front connected to it, but in the meantime, that is put together. Let's clean this up, make sure we don't have any little stragglers that are of hot glue that are going to interfere with the function of the microphone. Yes, so the button sticks up higher than everything else. That's what we want. Right there. I don't know if you can see that. Yeah. Button stands proud of everything else. So now that we're sure that the button is not going to be interfered with by any other part of the base of the mic, and that it is elevated enough to where it's going to make contact with the diaphragm, and we make sure of the same thing on this side, then it is time to actually apply the diaphragm. Now, on this ring, and I've printed out maybe an easier version to see, you'll see there's like a little flange on the inside, like a little catch. That part actually goes toward the base of it, so the little flange part goes downwards toward the bottom body of the mic. And what we're going to do is we are going to get our diaphragm material here, and we're going to set it carefully in place, and then we're going to place this over top of it. Again, this is experimental, so I don't know how well this material is going to work. Trying to get it all the way around at the same time. Okay, we got it. Ladies and gentlemen, that was a printing error. And the ring is supposed to be very tight, but it's not supposed to be impossible to get on. It had kind of mushed out near the bottom. Also, when you do put on any diaphragm, it's best to pull it tight and tape it in place, just so that it stays stretched the way that it's supposed to. And it helps if you've got 17 fingers per hand. That said, it is now going to be time to put this on, and we want to orient it so that this can butt up against the ones on the back, so that we can get both of the terminals put to the same, yeah, we want those separate actually. Yeah, the middle ones are going to be set to this terminal. And so what we do is we gently place this together, and that should stretch the diaphragm further when we put these together, and make sure that it is good and taut. So we have a nice little sandwich, and we can see that our individual terminals are going to be there and our ground terminal. So let me start by putting some screws in this thing, if I can find them underneath our paper. Now these are the only ones I had. They're way too long, so this thing is going to wind up looking like Sputnik. But that's okay, because it'll all work out regardless. Gently get those in place. And let's make sure that we are in fact recording, because I forgot to hit it a couple of times now. Yep, we have pushed the button, so life is good. We'll tighten these up kind of round robin when I finish. Now, to explain what we've got here, this terminal is going to connect to both of the buttons, and that is going to be our ground. And our positive signals are going to come in through each of these double buttons. And each signal is going to be affected by the fact that the diaphragm wiggles and it changes the resistance of the carbon material that we're about to put in. That makes it a variable resistor. So what happens as you talk is the resistance changes, the power goes into either side, it wobbles, changes the resistance, goes through to the buttons, comes out to here, and we have a circuit that changes as you talk. There we go. That's getting prettier for a given value of prettier. All right, let's actually, now that we've got these wires on there, let's put these wires on there, and we will screw those down. I should have done that before I put this together, shouldn't I? If I'd been smart, I would have, but I'm stupid. So now what I have to do is hold this with one pair of pliers while I turn it with another pair of pliers. So give me a second and I'll be right back after I do that. I felt like I also probably ought to put a washer on there so that it gets better contact between the terminals. So I did. Again, that one goes to both of your buttons. And what we're going to do is we are going to pull out our multi-tester. We are going to set it to continuity test or resistance, but it doesn't really matter. And we are going to make sure that this terminal now connects to this button. Woo, there it goes. See it? See the needle go? Whee! And we're going to check this button. Yep, they connect and everything is hunky-dory. So, we are ready to put the carbon in. Now, let's talk about the carbon for a half a second. We could probably also tighten these up a bit. But let's talk about the carbon for a half a second while we do that. What kind of carbon should you use? Well, it has to be conductive carbon. And I tried several things, and the first thing that I got my hands on after some experimentation was this. It is graphite flake, and it kind of works, but it's really noisy and it doesn't work well. I think it shifts around too much. It's not granular and it can flow over itself, and that makes a lot of crackling noises. So what I did get was this. Fish pellets, and you have to be careful because these are not all conductive. Some of them are, some of them are not. Now you'll notice that is way bigger than our microphone. I'm getting one out, and I'd rather have a longer one, because I want to show you this. This is what you have to do to make sure that you have the right kind, because the coconut shell will not work. It has to be conductive. So when you take and you put your probe on it, from one end to the other, you have to see continuity. This has to be electrically conductive. I don't know if you guys can see that or not. It has to be electrically conductive. See the needles jumping? If you don't get the electrically conductive stuff, it will not work. This particular brand, this ProCarb Laboratory Quality Activated Carbon, like $5 a tank, will do the trick. But you have to process it. And what I did is I put it in a bag and I hit it with a hammer, and then I strained it through a little screen like this into a jar, which happens to be a vitamin jar. And it comes out as fine granules. Yes. So, what we're going to do is we are going to fill up one at a time our carbon tanks, and we are going to put the end caps in. Now, before we do that, we probably ought to put our terminal posts through our end caps. And let's check this out, because I have a feeling that I might want the flatter ones, but let's check. Sorry, I've used the world's longest screws for this. And that's going to be our terminal post. Let's check and make sure that doesn't hit. And it does, unfortunately. So, we're going to have to try the flat-headed ones. I like using the brass because the brass is conductive and it doesn't do a lot of horrible things like corroding and stuff like that. Let's leave that a second. But these are flush screws, and so probably better for... Oh, I got crud in there. This print did not come out that well today, but that's okay. We will make it work. I'm coming up from the bottom, you'll notice. The flush flat side. And I should be able to drive this in so that it's reasonably flat against the bottom of the thing. There we go. Yeah, that should be better. Let me drive that in just a little bit further. We'll put the bolt on the outside of it to hold it in place. I'll go get a screwdriver and I'll make sure that that's flush mount. One sec. Here we go. We have got the screw mounted pretty much flush with this. and it comes to the outside, making a terminal. Now, what we ought to be able to do with that is to screw it in here, but we can't do that yet because we have to fill it up with carbon. And before we do that, actually, what I'd like to do is tighten up our screws on the outside to make sure that everything is nice and snug. There we go. That ought to do it. Yep. Good, good, good. Maybe we'll tighten that up a little bit more in a minute, but it's tight enough to be getting on with now. So, now comes the fun part. Getting a little bit of carbon into this thing. And I think we're going to use a spoon. Give it a little shake. Make sure all the granules are happy. You don't want them packed too tight. And now we're gonna see if this thing printed any kind of decent. So let's go ahead and screw this in. Okay, so we have one of the live terminals in. We've got it screwed in. We've got one of the ground terminals. We need the other live one. So all we have to do is, well, get one of the flat mount screws, fill this up with carbon, and we will have both sides of our double button carbon microphone completed. And then we can hook it up and test it out. Okay. We'll just get a little carbon. And we'll fill this up real quick. Not too much, like that might be a little over full. If you overfill these things, what happens is something called carbon packing. And if it packs, they can't vibrate enough, and you'll get very muted sound out of them. So let's try that again with a little bit less carbon. You want enough for it to constantly maintain good contact, but you want little enough to where you're not going to pack it in tight. There we go. All right, let's get the front button on real quick, which again is going to be a fun little challenge because this particular 3D print did not come out the best. Meaning we might need to give it a little encouragement. One sec, ladies and gentlemen. Okay, now that we've got both sides on, what we're going to do is now test our resistance. Now, you can tighten or loosen these on the back and on the front to improve or decrease your resistance. So what we're aiming for is to check between these two terminals and see what kind of resistance we have. Ideally, we're aiming for about 200 ohms. Well, I say that, but anywhere between 80 and 200 is fine as long as they're consistent between the front and the back. That one is 80. That one's a little lower resistance, so let's loosen it up a bit. There we go. Make sure they are consistent. Also, kind of tap your microphone to make sure the granules don't pack. There we go. That's about right. So now we've measured our resistance between all points. It's time to hook it up and test it out. So what are we looking at here? These are the circuits that drive our carbon button microphones. We have a schematic for a double button carbon microphone and a single button carbon microphone. But what do they do? Let's look them over real quick. Let's start with the ground side of the circuit, and let's start on the single because it's easier to read. Now, the double, it's just the identical circuit on both sides, bridged with a resistor, but we'll get into that in a minute. First of all, the ground side of it. We have the negative terminal of our 9-volt DC battery. It is connected to the ground on our microphone, and it is connected to the pin 1 of our XLR. And that's the ground side of our circuit in both cases. The top side of the 9-volt battery, the positive side, connects to a 900 ohm resistor to limit the amount of current, and then that goes through our microphone. So that creates power. That creates a bias. Our microphone needs power to bias the circuit in order to get it charged so that we can create sound with it. And finally, we have a 10 microfarad capacitor. And that keeps the 9-volt power from being able to flow through your XLR cable and into your interface. So capacitors like this keep DC from flowing. They only allow AC current to pass, as we know if we've had basic electronic theory. I would also note that these capacitors are listed as polarized capacitors, but do yourself a favor, get yourself a ceramic non-polarized capacitor. They work just fine in this circuit. They're easier to deal with. You don't have to worry about the direction of them, yada, yada, blah, blah, blah. That said, how does this actually function? So the 9-volt battery power provides a bias for the circuit. The resistor limits the current so that it gets it down to the level that we want. And when you talk, the diaphragm in this wobbles back and forth. And when the diaphragm wiggles, the part that the ground is connected to wiggles in the carbon, and the carbon becomes a variable resistor. And as the resistance varies, it changes the amount of power that goes between the ground part of the circuit going into the mic that's on the side of the diaphragm and the terminal that's at the bottom of the carbon chamber. So when it wiggles, the resistance between this and this changes. And since there's power flowing through it, the resistance changes, and the amount of power here changes too. So it actually creates a little bit of an electrical difference here, allowing a bit of power to flow between pins 2 and 1, back and forth and back and forth. And that is how we get our sound signal from this. Pretty cool, huh? So let's step over to the double carbon microphone, and what's happening over here? Well, it's the same circuit on both sides. There is just 2 carbon buttons, one on either half of the diaphragm. So one is on the back of the diaphragm, one's on the front of the diaphragm. And so when the diaphragm wiggles in and out, it reduces the resistance on one and increases the resistance on the other. So what this actually does with the double carbon microphone is it sort of balances the circuit, because as this one goes down, this one goes up. The 100 kilo ohm resistor that bridges them sort of evens that out a little bit and keeps noise down, and it's really great. So what ends up happening is you have a power difference between this part of the circuit and this part of the circuit, and it creates your sound waves over here across pins 1 and 3 and across pins 2 and 1. So that's how it works. It's very simple. And now we're going to go test it out. Okay, so I thought I'd start by saying this is not the microphone that we just built. It is the one that we are trying to copy. So if I turn it around, aha! Oh, sorry. This is actually what it's supposed to sound like, okay? So this is what we are aiming for. And unfortunately, we're probably not there. But let's find out. Okay, so first of all, we're going to hook the ground wire up to the ground terminal, which just screws on with a little nut right there. Same for one of the positive terminals. Since I made this one a little too short and the circuit doesn't reach, we're just going to clip a little alligator clip onto it and clip that directly to the other positive terminal, and away we go. Also, I've got headphones so that I can hear if I'm blowing y'all's eardrums out. Okay, so this isn't as good as the original. You can obviously tell. But it works, and it's something to play with and improve. So I hope you guys enjoyed this, and I hope you have fun building your own. I want to actually show you guys one more thing. Alright, real quick before we go, I thought you guys might want to hear once again what this is actually supposed to sound like, and not the almost there version from the 3D printed models.
It was a dark and stormy night. I don't know why I was talking like this. This is not my usual accent. I'm not from anywhere where this is a regional accent. But I knew one thing. They were shooting at me, and I didn't like it.
He finally left. The big lug didn't even buy me dinner first. So much for chivalry.
Alright guys, I will see you later. Take care. Bye. This is Duffy Weber with Hula Cow Studios in Cincinnati, Ohio. Thank you for tuning in today, and we will see you next time.